Is this okay?
Are we able to like screen record like the step-by-step process on calculator for us to go back to?
Yes, I can do that. I can do that. That's not a problem. Okay, so let's take a look at other examples and we'll do that. So which page am I on? I am on page 414. 414. Oh, and I don't want to forget. So hold on one second. I promised to determine that area. So let's determine that. So we have the integral from 1 to 7 from 1 over x squared dx. Remember, we got an approximate, what was it exactly? What did we get? What 1.49, correct. So that was our calculation using approximations. Okay, but now we want to determine it exact. So the integral from 1 to 7 from 1 over x squared dx equals, I need to know which function prime is 1 over x squared. And we had that in a little box on the side last time. So anyone remembers which function I differentiate to get 1 over x squared? Anyone? So please remember, a long time ago we talked about this. Anyone remembers how much is 1 over x prime? It's a very important rule.
Negative.
Yes.
1 over squared.
Excellent. So when I integrate positive 1 over x squared, the answer will be this with minus. And now from 1 to 7. Remember, this was an overestimate. So keep the negative outside, plug in 7, and subtract when you plug in 1. So it's basically 1 minus 1 over 7 when I distribute this. So 1 minus 1 over 7 is 7 minus 1, so this is exact 6 over 7, not 1.49. This is the exact. So let's do this again. So here are the steps again. Okay, so math, number 9, enter 1, enter 7, enter 1 over x squared, and of course dx. No integral exists without dx. And the answer should be 6 over 7, whatever that is, in fraction. It must be 6 over 7, otherwise something is terribly wrong. Any questions? Oh, I didn't mean to do that. Actually, I meant to go back to the book. Okay. Good. We can choose anything you would like. We can determine areas. Now, when you look at this area, see, all these pieces are under the x-axis. These areas will be negative. All the positive areas are above the x-axis. So here, it appears that this area is bigger than this, so I'm expecting a positive answer. That's what I see, but maybe not. Maybe this area, maybe my eyes, are playing tricks on me. Maybe this area is bigger than this. I don't know, but it appears that this is bigger, maybe. But definitely here, this is positive and this is negative. So the answer will be negative because this is a much, much bigger area. Here, to me, it appears that these two are exactly the same, one positive and one negative. So then the answer must be the integral from -1 to 1 If this is positive and this is negative and they are equal, what will be the answer?
Negative.
0.
Oh.
So if this is 5 and this is -5, when I add them, I get 0. What about this one? Will this one be positive or negative?
Negative.
Yes, because this is the x-axis. Everything is under. Very good. So please choose anything you like from 35 through 58. Anything you want. We learned how to determine definite integrals today, how to evaluate areas without approximating with those rectangles and dividing the subinterval into subintervals, yada, 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 yada. Now we know how to calculate a definite integral. So please choose, or I will. No one wants to choose? I will choose 45. In 45, we have the integral from -5 to 2 e to t dt. Of course, if the variable is t, then we have to have dt. Perfect. It's a definite integral. I have to check that this function is continuous between these two, of course. E to t is continuous everywhere. It looks like this. Continuous everywhere, like polynomial functions, no problem. Now I have to find the antiderivative. Which function prime is e to t? Which function I differentiate to get e to t?
E to t over t.
Over 1. Right, e to t. So from -5 to 2. I plug in 2, and I subtract when I plug in -5. I have no idea what this is. I can approximate. So with the graphing calculator, I will say, I will plug in e to squared, and subtract when I plug in e to -5. Good. I can also use math and number 9 to check that from -5 to 2, from e to t. I didn't mean that. From e to t dt, of course. But I don't have t in the calculator. So when I click enter, I have to get this gibberish. Whatever that is, that's what I have to get. So approximately 7.38. Good. Back. Anyone would like to choose anything? Let's determine this one or this one. It's up to you. Let's choose one graph and move on to other problems. Which graph would you like to find the area for? The shaded area? No preference? Okay, so let's use 35 then. See, it already gives us what it is. It's the integral from 0 to 1.5. 0 to 1.5. From 0 all the way to 1.5 from this function, x minus x squared dx. Now let's see if it's a positive or negative. I think this is bigger than this, but who knows? So the integral from 0 to 1.5 from x minus x squared dx. Good. So I have to find the antiderivative. Once I have the antiderivative, I'll go from 1 to 1.5. Which function prime is x? Anyone? Which function prime is x? Please.
X squared over 2.
Thank you. Minus which function prime is x squared? Very good. Luckily, it's a polynomial, and when I plug in 0, everything is 0. So I don't need to at all because it's a polynomial. But I have to plug in 1.5, and I will not plug in 0 first. I have to plug in 1.5 first. Minus, when I plug in 0, I get 0. So I'll calculate this. 1.5 squared divided by 2 minus 1.5 cubed divided by 3. 1.5 squared divided, yep, yes. And look at that. Okay, interesting. I did not expect that at all. To me, this appeared to be a little bit bigger, but okay. So from 0 to 1.5, it was all an illusion, I guess. X minus x squared. Remember, you plug in the function here, not the antiderivative. Be very careful. And the answer should be 0. Okay, wonderful. It's a surprise.
So
yes?
the areas are the same?
Yes.
Okay.
Yep, it was an illusion. I thought that this would be a little bit bigger and then this. So then the result would have been positive, but apparently they're completely the same. Good. Anyone would like to pick anything from here? Let's pick something from here. Anyone, please? Anyone would like to pick a problem from here? Don't be shy, yes or no. And if not, I will pick.
53.
53. Let's look at 53. Perfect. Where are you, 53? Okay, very good. The lower limit is natural log 3, which is a number. That's fine. The upper limit is natural log 7, another number. No problem. 4e to negative x dx. Perfect. Very good pick. So all I need to do is find the antiderivative. So 4 is 4. Now the question is, which function prime is e to negative x? So imagine or remember what we did with 2. If this were 2, we divided by 2. If this were 4, we divided by 4. But now it's negative 1. So what function prime is e to negative x?
Is it negative e?
Yes, e to negative x divided by negative 1. The power has to stay as is. Let's check. When I differentiate this, I have e to negative x times negative 1. That will cancel with this, and I get this back. So I will have negative 4 e to negative x from natural log 3 to natural log 7. Any questions before we calculate further? Is this clear, everyone? Yes, no? Is that okay?
Yeah.
Okay, so we'll keep negative 4 outside, waiting patiently. I have to plug in natural log 7. Sorry. E to negative natural log 7 minus e to negative natural log 3. Good. So it turns out that there is a formula for these two, or you just plug them in the calculator. So the formula is I have to bring the negative 1 as the power of 7. So this number becomes 1 over 7. And this number becomes 1 over 3. we did not review this particular situation when we looked at chapter 2. So a to log base a of x is x, or e to natural log x is x. So this is a property of the natural of log functions that we did not super emphasize in chapter 2. So I don't expect you to do this, but I will show you with the calculator. So this is -4, and this becomes 1/7, and this becomes 1/3. And we'll do this with a calculator. So this is -4/21, and this is 3 minus 7, which is -4. So this will be 16/21. So you either plug this in the calculator, or you start and you check your answer with this. So you can also copy what you see, but maybe it's more difficult to copy and adjust. Let's not adjust. So let's go directly to 9. And we have the lower limit natural log 3. The upper limit natural log 7. And we are looking at 4 e to -x. Of course, dx. And press enter. And we should get 16/21. Of course, we are going to get some gibberish, but we can plug in 16/21, which has to be completely and identical this, or we change this into a fraction and we get 16/21. Okay. So I like to look at a word problem as an application here. Business total revenue, increasing total cost, accumulated sales for the first 5 days. Yep, let's do accumulated sales. We haven't done accumulated sales before. I don't remember. So what is that? 63. Okay. So we are given S prime of t, which is the rate of change. Sales are growing continuously at the rate of change of sales. S prime of t equals 20 e to t, where S prime of t is in dollars per day, of course. So why? It's a rate of change. It has to have 2 measurement units. Find the accumulated sales for the first 5 days. So part A, the sales on 1 to 5. The sales on 1 to 5, remember, we find the area under the graph between 1 and 5. That will be the total sales. So if we graph this function, which is the rate of change, and we determine the area, what is the area? It's the integral from 1 to 5 under this graph. Of course, dt. Do not forget dt. The integral does not exist without dt. So, as we explained last time, if this is the function between 0 and 5, I'm sorry, between, yes, 1 and 5, then the area under the graph will give us the total sales. So we have 20. What function prime is e to t? Or we know is the easiest one, from 1 to 5. We plug in 5 and subtract when we plug in 1. And we calculate this in any way you want, but you have to at least write what I wrote and plug in the numbers. So you can approximate, or you can just use 9, again, the integral, and this is from 1 to 5. And this is from 20 e to t, Where is my e to t? E to t, and of course dt, but I don't have t in the calculator, I have to use x. And I get this. Let's see what I got with 20. You cannot change that into a fraction. That's not possible. This time, e to the 5th power minus 1. Minus e, sorry. I have to get the exact same thing. If I don't, something is wrong. So the total sales, oh, I didn't copy it, sorry. Total sales 2913.90. 2913.90. Of course, dollars. So these are the total sales between 1 and 5. Any questions? Any questions? Now they're asking us, and I will stop, I promise. I just want to look at this. Okay, so the second part is find the accumulated sales from the beginning of the 2nd day through the 5th day. What should I do? Just integrate between 2 and 5 this time instead of 1 and 5. That's all we needed to do. Okay, I know I have to stop. Sorry about that.